Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Rizal bin Azlan dari Grup 7 Seksyen 3. Baik, di sini soalan pertama yang kami diberi di dalam lab sheet ialah from lab 2 PCB layout, please set your artwork. So, inilah contoh artwork saya daripada protest yang kami telah buat di lab 2. So, layout ni kami akan gunakan di lab untuk membuat PCB nanti. So, ni tak ada komponen supaya senang nak etching semua nanti. So, next, what is the UV exposure effect on the PCB substrate? So, di sini, the UV exposure effect is the process of transferring the printed circuit layout to dry film of the PCB. Jadi, UV exposure ni digunakan untuk, daripada circuit kami ni, kami nak letakkan ke PCB kami menggunakan UV exposure ni. Jadi UV exposure ni akan the UV light, the process is done by applying the attached UV light to the photoresist that is on the PCB, which will expose any area of the copper laminate that are meant to be kept. So jadi bila UV light ni kita gunakan, hanya line-line yang perlukan saja akan ditransferkan di PCB kami nanti. So, sebab itulah kami gunakan UV light exposure tu. Dan satu kelebihannya lah, dia UV light ni akan membuatkan line, iaitu line correction kami ni lebih accurate dan precise. Dan soalan ketiga pula, what is the developing process? So, development process ni ialah proses untuk membuang benda-benda yang unhardened portion of the photoresist which done in the UV exposure process. So, mana-mana yang photoresist yang tak keras akan dibuang oleh development process ni, dan ia akan dibuangkan menggunakan sodium carbonate. So, by doing this, only the desired portion of the PCB, which is the routing of the PCB, is shown. So, yang kami tahu, hanya yang hitam ni saja yang akan dihasilkan di PCB kami nanti. Yang selainnya akan dibuang. So, apa yang kami dapat observe dari video tu ialah, after the development process, the routing circuit on the PCB becomes darker due to the hardening of the photoresist that remains on the PCB, and that all the unhardened photoresist is removed.
Assalamualaikum and very good day to our lecturer. My name is Muhammad Har Aizat Barum and my matrix number is CE190134. So today I'm going to explain about question 4, 5 and 6. For question 4, the question is, what are the procedures of etching process? So as we know, PCB etching is the process of removing copper from a circuit board layer that is not protected by the hardened photoresist by immersing it in a chemical solution. The etching used by industrial circuit board fabricator is broken into two different processes, acidic etching and alkali. So these are the steps for how to complete a etching process. The first step is a board designing. Second step is print out the design into the shiny side of the transfer paper, and the third step is sand the copper plate so there is a rough surface for the design. Next is wash the copper with some water and rubbing alcohol and let it dry. For the fifth step is cut out the designs and place them face down on the copper. Next, run the copper plate with the design face down through a laminator until the plate is hot. After that, after running the plate through a laminator or iron, place the plate into a cold box and agitate until the paper floats off. The next step is place the PCB into the etching solution and agitate for about 25 to 30 minutes. And once all the copper is gone, rinse it in the water bath, let it dry and use rubbing alcohol to whip off the ink transferred into the PCB. And the last one, you got the etched PCB board. Okay, so these are some of etching process. The next question is how exactly to do the stripping process in this lab. Post etching process The copper present on the PCB get covered either by electroplated tin or tin lead. You can use concentrated nitric acid to remove the tin. Or nitric acid is very effective in removing tin and does not damage the copper circuit tracks below the tin metal. Thus, now you have a clear distinct outline of copper on the PCB. The board can now be passed on to the next process. So here are steps that we do on triple process. The first thing is a solder resist. This is the one of the most important processes in designing of a PCB. The areas on the circuit board that cannot be soldered are covered with a solder resist material. By doing this, it avoids the solder from forming traces which can create short to nearby component leads. The next one is a PCB testing. Once the circuit board is manufactured, the next step is a testing. This check whether the manufactured printed circuit board is working fine or is defect free. Today, high volume PCBs are tested using a number of advanced testing equipment. Okay, so this is the final step, which is include assembling various electronic components in their right position on the circuit board. PCB assembly can be carried out by either of the following method. The first one is surface mount technology, and the second one is through hole technology. So the last question that I'm going to explain about the importance of the need to be aware of safety signs and the use of PPE, especially work related to the chemicals. The purpose of having a safety sign at the workplace is to identify and warn workers who may be exposed to various hazards. According to OSHA law, keeping workers safe is an employer obligation. Having a visual communication strategy, for example, safety sign, is a key. Safety sign assists in the communication of important instructions, reinforce safety message, and provide instruction for emergency situation. Okay, the last one I'm going to explain about the importance of PPE. So as we all know, PPE can protect us against chemical and physical hazard exposure. It is important to be aware of the hazardous materials you work with or which you may come into contact with, and adjust your PPE accordingly. Evaluate the scale and any deviation from your procedure, as this may influence a change in the protection required. So PPE must include eye protection, we have glove, maximum skin coverage, and closed-toe shoes. In some cases, protection such as apron, respirator, splash shields, earplug, and specialized glove may be recommended or required. In this photo, these are some of example for our protection. Here we have safety goggles, we have a lab coat, we have glove, we have long pant, and last but not least is closed-toe shoe. So that's all from me. Thank you.
My name is Muhammad Iskandar, and I'm from Group 7, and I'm here to talk about the discussion and the conclusion that we got from lab 3. From the lab that we got is that uh, this lab is about the construction of the PCB. Mostly primarily about the material used as a base, which is to conductive strip that are printed on the board. Um, Mostly this PCB the base material for this are the fiberglass, and the conductive conduction are generally copper and are made from etching process. Okay. Uh, in this lab, the PCB that we handle contain about two type of PCB, which is one is the single-sided, and the other one is double-sided, which is on both sides of the PCB. Uh, the single-sided is more easier than the double-sided, but the double-sided is hard to manufacture uh, than the single-sided, because the double-sided, yes, double-sided in front and the back of the PCB. It can run. We can the copper can both of the side, and it can run from both of the side. It's easier to design the board, but double-sided is hard to manufacture than the single-sided, which is hard to design but easy to manufacture. Okay, in this lab, we should go to the lab, but due to COVID, students only learn it from at home, and some of them at campus. Student mostly learn the process of this PCB during the classes. And one of the process is print layout, which is we print the designated circuit on the PCB that we got from Proteus in the negative form. Then we go to the PCB preparation, which is we use a cutter to cut the PCB to its size. Then go to the melting dry film to cover the PCB with dry film. Then we expose it with a UV. Next is that we develop the process using developer machine for 1 to 2 minutes. 1 to 2 minutes, and we will see the photoresist come from the PCB will start coming off. And then next is the etching process, which is etching at for 5 to 10 minutes, depends on the heater and bubble area that not covered by the film. And then you can see the copper will be created to match the film. And then the stripping process, which is to remove the dry film, resist leaving the copper that we make on the Proteus, we will see on the board. And lastly, the drilling process, which is we drill the hole for the component that we want to put it. Okay. And lastly, about the conclusion that we have been made that students will theoretically know how to make the PCB with the video and the notes that we have been given. We will know what the process from the PC print layout to the drilling process. Uh, Even without going to the lab, student will know how to make the PCB even at home. Okay, I think that's all from me. Thank you.